Hello, today I'd like to explain something about SIKA, Temperature Calibrator TP Premium regarding switch tests. So, for example, I define 3 test points. We have a starting point, a low point and a high point. And the low point and the high point is the expected switch point. So in between, for example, 48 and 50 centigrade, I expect the switch point of my temperature switch. So the temperature starts at test point number 1, rises, comes to low point, to the low point, and temperature rises still, and then maybe the switch switches, and this is the first temperature. It's recorded with temperature number 1. Then temperature increase again to the high temperature point, and then the temperature starts to decrease, and again the temperature switches. So that means the temperature T2 is recorded, and after recording of T2 the temperature goes down to the starting point. I like to explain it now on the calibrator. So you see the calibrator is in front of me. As I mentioned before, I have 3 test points. I have the dry block functionality, I have the device under test, and the data acquisition. Let's go to the test points. As I mentioned in my example, my start temperature is 46 centigrade, the low point is 48 centigrade, and the high temperature is 50 centigrade. So I expect a switch point in between 48 and 50 centigrade. So you can imagine here we have the curve. So this is everything regarding the switch points. If you like, you can of course edit and change the points. So open, edit, 48, whatever, and so that means you can program different points. My starting point is 46. I confirm this, so everything fine. I confirm this, and the device under test. In my case, the device under test is connected to channel A. It's a switch, yeah, and I can check also here if everything is well. This is the switch. I can go in and edit something. So the name is switch, serial number, last calibration date, waiting time, minimum temperature, maximum temperature, the stability time, type is the switch, tolerance class is switch, and here you can program normally open or normally close. In my case we have a normally open switch. I select normally open switch, I confirm this, so that means I have all the settings regarding the switch. Switch is connected, the cables of the switch is connected to channel A, I confirm this, and then I have to select the data acquisition. It's the measuring device, and for the measuring device we have different possibilities. We can connect an RTD thermocouple and milliamp volt input, and in this case you have to select measuring device regarding switch. Here you see the other possibilities. Select the switch, and then you have the possibility to give also a record name. So for example, I name it test, I confirm it, and I confirm, and so my process then will start. The calibrator will heat up to 46 centigrade to the starting point. I start. So it changed over. The process is running now, and you see the first test point is the starting point. It's 46 centigrade. The calibrator now heats up, and then of course it will take a time to get to the temperature. So we approach the temperature, it's heating, we use an external reference, the functionality is an air shield function. I have some settings regarding linearization, and we have the data equation with some values, and if I go to the live graph, then I can see the temperature now is rising to the first point, to the starting point, up to 46 centigrade. So this takes time, and let the calibrator work. I can select between the standard screen, yeah, this is the standard screen, and of course I can also show some information on the live graph by switching over to the live graph. And remember, we like to come to start, and I programmed 46 centigrade. Yeah? So you can see we reached the desired point, the 46 centigrade, and then the calibrator changes over to the next set point of 48 centigrade. This is the low point. Now on the screen you can see the temperature is still rising. We had the 46 centigrade and now it changed over to 48 centigrade. You see here 48 centigrade and the current value is 46.3. We can change, and here you see also the next test point, that's the low point, is 48, and the current temperature value of the calibrator is 46.7. The gradient is 1 degree Celsius per minute, and so it heats up. Red light means heating up, and the flame, it's heating. So the calibrator reaches the low point. Remember, our low point here is 48 centigrade, and now we are in the area of the expected switch point. And in our case, for example, the calibrator reaches or switches, for example, at in the range of 48.5 or something like this. Yeah, so that's my expectation. Let's see, temperature is rising, and the calibrator will reach the high set point of it's 50 centigrade. Yeah, and so now we are in the range, and then the switch switches. That means the contact will be close, and then you see we record a value of temperature T1. So remember, we are on this point, we have a recorded temperature of T1. Yeah? In our case, T1 is recorded at 48.7 centigrade. And we have the test point, the high point, as 50. That means the calibrator heats up to 50 centigrade now. Yeah? And if we reach the 50 centigrade, then the calibrator cools down again. So in our case, again back to 48. Yeah, we reached the 50 centigrade, and now the calibrator is cooling down again to the low point to detect the point by decreasing temperatures. You see the curve, we have an overshooting a little bit, that's clear, but it takes time a little bit. We approach the next point, that's the low point, 48 centigrade, and here we see the ice star. So now it's really working and cooling, and the gradient now meanwhile is minus 0.4 centigrade, and so the calibrator cools down. Remember this picture, we reach the 50, now we come to the low point. The low point is 48, and that means now we like to detect temperature T2. So I expect it would be in a range of so let's say something as 47 centigrade, something like this. I go back to the graph, and we see the set point is 48, the current temperature of the calibrator is 49, temperature is decreasing. We like to reach the 48, the low point. So, and then we recognize that the switch. In our case, we have T2 on a value of 48.4 centigrade. So that means we have the increasing temperature of 48.7 and the decreasing temperature of 48.4. That means the hysteresis of the switch is 0.3 centigrade. And now we come back to the to our starting point of 46 centigrade, and that's all what you can record. Yeah. If now we have to wait until the calibrator comes to 46 centigrade, and then a small bell will ring, and then the complete process is recorded. Go to the live graph. We see from 48 down to 46, and now the temperature is decreasing and it comes down. And then I like to show the acquired datas, recorded datas. Our test point is 46. Now the test task is complete and successfully, and so I can confirm. I go back, I have the values here, and I can stop my task, and the data acquisition is this direct. Oh, sorry, I like to read out the datas. Wrong. I like to read out the datas of my test, and then I have the values I like to see, the graph, and then I can zoom in and zoom out a little bit, and here I see the curve with the recorded points. I can even trace the values, and if I see if I'm with the trace on the point, I see the values of 48.7, and the second value is also recorded as 48.4. Yeah, that's it. So you have all the values stored in the calibrator, and you can see the recorded graph, and that's it what I like to show.